All right, number 4, we're going to test hypothesis using the p-value approach. So this is similar to what we just did in number 3. So that information is still here. And we're just going to go through and do the stat crunch. So it says be sure to test the requirements. So here they are asking us to verify that n p naught and 1 minus p is greater than 10. Okay, so we're going to check that that is the case. So we're going to turn this on. We're going to do n 125 times, so the sample proportion is equivalent to this, so even though they're saying use the sample, we're going to use the p. So 1 times 0.2, and then 1 minus 0.2 would be 0.8. So we're going to multiply these 3 together. That is 20, so look close to what we just had last. So since that is bigger than 10, is this greater than 10? Yes. I'm going to check that. Okay. Now, the next it says use technology to find the p-value. Okay, so I'm going to go to StatCrunch. We're going to go to stat. We're going to go to proportion, 1 sample summary, number of success, X was 30. Number of observations, my sample size, 125. We are looking at the sample proportion being 0.2, so I'm going to change this to 0.2. And we want a right-sided test, so greater than, change this to greater than. Alpha is 0.05, so that is going to be fine. We're going to click show the critical value, and then we're going to compute. So the p-value for this right here is giving us 0.1318. They want us around the 3 decimal places, so 0.132. And then the conclusion would be, so since p-value is 13% and alpha is 0.05, similar to the previous problem, ours was 5 though, but the 13 is much bigger than 5, so we do not reject. We only reject when p is less than. So if p is bigger than this, we do not reject. So we do not reject the null because p is greater than alpha. All right, number 5, we're going to do this one as well. So test hypothesis using p-value approach again. So we're going to make sure the p-value is greater, we don't reject. If it's less, we reject. That's the criteria. So we're going to go to StatCrunch. We're going to go to stat, proportion, 1 sample with summary. Number of success 125, that's my X. Specific characteristic, number of observations, N is 150. The proportion, population proportion we're estimating is 0.9. And we are doing a left tail test, so less than this time versus equal to. So we're going to go to less than. And alpha is 0.05, level of significance. So I'm going to come down here and say show critical value, and then we're going to compute. So it gives me my output. I can see that my p-value is 0.0032. We want to round to 4 decimal places, so I'm going to put all of those 0.0032. All right. So comparing 0.0032 to the 0.05, if I drew this out, okay, so that's 5% and that's almost 1%. So I'm giving myself a 0.05 error, and this is alpha, and then my p-value is like way over here. Like there's very, very small chance that this could happen, and it has happened. So this is really strong evidence. When P falls in this area, this is the rejection region. So if P is over here, it's less than alpha, we reject the null. This means we have strong evidence against it, meaning the alternative is true. So that being the case, we are going to, P is greater than alpha, no. Since P is less than alpha, do not reject, nope. Since P is less than alpha, reject the null. That's what we're going to do.